Hello and good day, Algebra. We are moving on with CO2, not carbon dioxide, but estimating the root of a non-perfect square. You may remember this from last year. It was CO12 in pre-algebra. So you've done this before. What is a root? How would you define the root of a number? Yeah, Cade. Yeah, sure. It's a number that when multiplied by itself, or when squared, equals a given value or number. We'll use value. So kind of a wordy definition to really describe something rather simple. A number that, when multiplied by itself, equals a given value. So how we'd use this is if I ask you for the root of 49, the root of 49 would be the number that, when multiplied by itself, equals the given value of 49. What would the root of 49 be? 7, because 7, when multiplied by itself, equals the given value 49. Okay. How about the root of 144? 12, because 12 is the number that, when multiplied by itself, okay, equals the given value of 144. And so then we get into two types of roots. There's the perfect square and there's a non-perfect square. Okay. A perfect square, we talked about this with our rational, irrational, right? 49 and 144 are both examples of perfect squares because why?
They both have a square root that's a number that doesn't have decimals.
Sure. A number with a root that is whole. Okay. A perfect square is a number with a root that is whole. I believe we got into this a little bit yesterday. The reason why it's called a perfect square is if you draw a square with an area of 144, what are the lengths of its sides? They're all going to be 12. Because 12 times 12, how we'd find the area, we're multiplying something times itself because it's a square, equals 144. An example of a non-perfect square would be like if we had a figure with the area of 10. That can't be a square, can it? Because nothing times itself equals 10. We can multiply 2 and 5 to get 10, right? So it would be a rectangle, 2 times 5, but it's not going to be a square. So a non-perfect square is a number with a root that is a decimal. And like we talked about yesterday, those roots of non-perfect squares are always going to be irrational values. Right? A number with a root as a decimal. Right? So this chart here can go on a help sheet. We're going to go through what all the perfect squares are and their roots. So the first perfect square is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We'll go 1. What's the root of 1? What times itself equals 1? 1. We like that. That comes in very handy with the 5-card challenge when you have a 1 to use because the root of 1 is still just 1. How about a 4? What's the root of 4? 2. 2 times 2 equals 4. The root of 9 is 3. The root of 16 is 4. What will come next? The root of 25 is 5. Root of 36 is 6. Root of 49 is 7. Root of 64 is 8. Root of 81 is 9. Root of 100 is 10. Root of 121 is 11. Root of 144 is 12. 169 is 13. 196 is 14. And the root of 225 is 15. And these perfect squares are going to be very, very handy for what we're going to do in a few moments, which is estimate the root of a non-perfect square. Everyone got that down? Well, you can watch the video. Don't forget to like and subscribe. Okay. Quentin, give me a number between 1 and 225 that's not in that table up above. 24. Okay. So if I ask you for the root of 24, you could either just use your brain and think about is 24. What can I multiply to get 24? There's no number that when multiplied by itself gives me 24, right? You can do 2 and 12, 4 and 6, even 3 and 8, but nothing times itself. So if I ask you for the root of 24, you know it's going to be a decimal value. And our goal today is to kind of narrow down what's an estimation of that decimal. It's irrational, so it never ends. I'm not going to ask for the entire thing, but just an estimation. Yeah.
4.9.
And how'd you come up with that?
Because 5 is 25 and it's pretty close to 25.
Right. So why that table you have up above, Sophie, is going to be helpful is because, the root of 25, you've got that listed, and you know the root of 25 equals 5. Okay? So root 24 being just a little bit below 25, it means that it's going to be just a little bit below 5. You even go a little bit further and say, well, the next smaller perfect square is root 16, which is 4. Again, using that table up above. So you know that the root of 24 is going to be somewhere between 4 and 5. Kind of narrows it down a little bit. You won't be able to use a calculator on this part of the test. And so using one now, helpful to check your answer, but you're going to want to know how to do this part also. But knowing that the root 24 is between the whole numbers 4 and 5, Burgess then said, well, I know it's closer to the root of 25 because it's 24, it's only one off. So it's going to be closer to 5 than it is to 4. And he came up with 4.9. I would also accept 4.8. Okay? Because again, this is just an estimation of it. Any questions on that process? Cade, give me another number that is not in the table from up above. Maybe something between 100 and 200. 174. Okay. So asking for the decimal value, the root of 174, right? Again, we're going to want to look for those perfect squares on either side of it. So look at your table, and where does 174 fall? What two perfect squares is 174 between? Sorry? Okay, so those are the root values, right? But the actual numbers themselves, the root of 169, which is 13, and the root of 196, which is 14. Okay, so both pieces are important here because now we have to look at what is 174 closer to. Because being closer to 169 means its value is going to be closer to 13 versus being closer to 196 would mean the value is closer to 14. So you need both the original roots and the perfect squares there. Both are important. Root 174 is closer to the root of 169, which means it's going to be closer to 13 than it is to 14. Give me a decimal answer, an estimation that you might use here. 13.4. Okay. 13.3, 13.2, 13.1 even. Basically anything that's below 13.5. Why would 13.5 be a definite poor estimation here, Haley? Because then 174, you're saying that's like halfway between 169 and 196, which it isn't. It's only 5 away from here, and it's what, 22 away from there? It's clearly closer to 169, so your value is going to be clearly closer to 13 than it is to 14. But again, it goes back to that table up above and be able to interpret that and what it is saying. Okay. Pick one from the work down below that you want to do together. Jack.
How do you do negatives?
This exact same as positive, only make your answer negative. If this had been a negative 174, then our answer would be a negative 13.4, negative 13.3, negative 13.1, negative 13.2.
Oh.
The process is exactly the same, only just make your estimation negative. Okay? Would you like to do one of those?
Yeah, let's do the 215.
Sure. The negative root of 215. What two perfect squares is 215 between? Blake, we're on this one now. Hold on. Save that thought. What two perfect squares is the root of 215 between? I'm ignoring this sign for now. I'm just going to apply it at the end. Okay, but yeah, Cade? The root of 196 and the root of 225. And if you're saying, whoa, Cade's so smart, how do you know that? He is smart, but it's also up in your table, right? That table that we filled out, just look for where 215, what two numbers will that be between? Those are your perfect squares. And then you know that root 196 is 14. The root of 225 is 15. So you know that the root of 215 is going to be between those two values. Which one will it be closer to? Closer to 14 or closer to 15? Closer to 15 because 215 is closer to 225. So it's not going to be 14.1, not 14.2, right? Those are all closer to 14. We're going to probably start with 14.6, 14.7, 14.8, somewhere around there. It's an estimation, so it doesn't have to be perfect. And now, since our original number was negative, we make sure that we add that negative sign into our final answer. Okay? So positive, negative, the process, the procedure doesn't change. It's just that your answer is going to be negative. Johnny? It could be. It'd be better than 14.1, right? I mean, it's 10 away, so it's not right up against it, but I would accept 14.9 also. Any questions, comments, concerns, complaints, compliments, or congratulations?
Congratulations.
Thanks, Johnny. For what?
For everything.
Yes. I missed that all summer long. Okay. Your homework for tomorrow is to practice this. I want you to do the rest of this first page and just the first 4 on the second page. Okay? Another opportunity for the number game is prevented itself. Yes, so the rest of the first page, and then the first 4 on the second page. Okay? All right, let's give my outro a try here. That's how you math.